In this lesson, we're going to be talking about Linux file systems. So I am logged into a Linux system and I'm in via SSH, although I could do this using a GUI, and there are GUI tools to do the sorts of things I'm going to be doing, but I'm just going to do it via the command line so we don't have the distraction of the desktop to look at some of the things that we're going to be looking at. So we're going to be talking about file systems here. Now, I've got my primary file system you see in the top line is DevSDA2, and that's mounted on root, which is designated here by a slash. Now, that's the type ext4, so that's my file system for this particular operating system or this particular system. So I've got an ext4 file system. ext4 actually goes back to about 1993, where it started life as ext2, and that was really the original Linux file system was ext2. Now, ext2 implements some of the basics of Unix file systems. So the Unix file system has sort of a basic structure in terms of the directories and layouts that it has. So we've got things like bin and user and home, and we've got all of those directories, and they are laid out as a hierarchy. All of the files and directories are stored in these things called inodes. Now, inodes represent files or directories, or maybe another way of putting it is files and directories are represented by inodes. So every file has an inode that's associated with it. In addition to kind of this directory layout that we get with this file system, we also get these permissions. So on the left-hand side here in the columns, you've got this notion of permissions. So we've got three different sets of permissions: user, group, and world. So on, for example, the etc directory. Now, the user that owns the etc directory or etc directory, I can actually see here in the third column, it's the user root. So the user root has read, write, and execute permissions. And you'll see that in the left-hand column, the first letter is a D, which indicates it's a directory. And we get read, write, execute as the first group of permissions. So that's for the root user. Now, the second block of permissions, which also could be read, write, and execute, except that the write is not ticked off for that particular section, that would be for the root group, and that's the fourth column from the left. So the fourth column indicates the group that owns the file. And finally, on the right-hand side of that first column, we've got three permission settings that's for world, or basically everyone else. Everyone who's not the owner or part of the group, those are the permissions that you get. So that would be read and execute, just like group. So the ext2 and all subsequent ext file systems support this Unix idea of three blocks of permissions for user, group, and world. And those are the only abilities we have to set permissions. You can't, unlike Windows, for example, where you can set individual custom permissions for a user at a time or on a per user or per group basis. With Unix, you have one owner, one group, and then everybody else. So I don't have the ability to say, Johnny, you get read permissions to this particular directory where everybody else doesn't get read permissions to it. So I've got these three blocks of permissions, and that's part of sort of the Unix way of doing file systems and the Unix way of doing security on individual files and directories. Now, I've also got the ability to set an owner and a group here. And again, that's embedded into the file system. So I mentioned that ext2 goes back to 1993. The successor to ext2 was ext3. The big difference between ext2 and ext3 is the idea that it supports journaling. So with journaling, I have the ability to store changes to the file system. So when I store changes to the file system, I actually can roll back those changes. So let's say the power goes out, and when it comes up, the system discovers that there are some files that are missing. It does that by checking the journal against the live file system, and if they don't match, we can reapply the changes in the journal to the live file system to bring it up to date. So I get journaling with ext3. I mentioned that this is actually an ext4 file system. The big things that ext4 adds are performance enhancements, and it also adds support for large file systems. So ext4 has the ability to store really large file systems, well above the gigabyte range that mostly you're used to dealing with. So we now have really large file system support, and we've got some performance increases with ext4. Now, I've brought up a little utility called Tune2FS, and what it shows is different statistics around this particular file system. So you'll see the file system features. We have the journal, we have extra attributes, we can resize inodes, directory index, file type, needs recovery, and you can see all of the different file system features. Now, the file system is flagged as clean, meaning it's been checked, and there's actually two states there. There's dirty and there's clean. A dirty file system needs to be checked for integrity against the journal or whatever other mechanism is in place to ensure its reliability. So the file system OS type is Linux, and we can see the inode count, the block count, and all of these other statistics for the file system. You can see lifetime writes has been 205 gigabytes, which doesn't seem like an awful lot considering that the drive that it's sitting on is 320 gigabytes. Now, I've been talking about the ext family of file systems. There are actually other file systems that run under Linux, and they support a lot of the same features, certainly in terms of things like permissions, and journaling is a pretty common feature of file systems or modern file systems. So, for example, we've got JFS, which is a journaling file system. We've got XFS, and we've got RicerFS. Those are other file systems you may run across with a Linux operating system as well. And like I said, they'll support permissions and certainly the same directory structure as ext2, ext3, because the directory structure is really part of the way the operating system works. And as I said, the journaling has really been a feature for at least the last 10 years of most operating systems and the file systems they support, because it's such a useful feature to have when we have things like power failures, which is really common when you're running a desktop operating system, because you probably don't have a UPS and power conditioners and all of that where, you know, server grade systems may have all of those things in the background. You may not have as many catastrophic failures on a server as you would on a desktop. So pushing this journaling feature down to the desktop has really been a good thing. And as I said, modern operating systems and modern file systems have all supported this journaling ability. So most of the time you're going to run across the ext family of file systems under Linux, but don't be surprised if you run across a JFS or an XFS or a RicerFS file system from time to time as well.